All right, so here we are with lesson 4.1, law of sines. All right, law of sines, something we use for oblique triangles, would be non-right triangles. Remember that we've spent a lot of time this year solving right triangles, and with right triangles, we will be using SOHCAHTOA to solve for missing sides and angles. So here we're talking about oblique triangles that are either acute or obtuse. All right, both varieties are the sort that we would use law of sines to solve. Okay, so some of the cases where we will use law of sines to solve for oblique triangles would be if we know one side and two angles. All right, so that would be we can do angle angle side or angle side angle. Okay, if we know two sides and an angle opposite of one of those sides, all right, that would be angle side side. Okay, and that's a special one that we're going to talk about. And then two sides with the included angle, that would be case 3. So that'd be side angle side, and then all three sides would be side side side. So what we're going to figure out today is that these two, case 1 and case 2, are both of the sort that we will use law of sines to solve. Okay, case 3 and case 4 we're going to look at tomorrow with law of cosines. So case 1 and case 2 is law of sines, and case 3 and case 4 is law of cosines. So let's take a look at what law of sines is here by definition. And typically the way we're going to see this is the sine of, say, angle A over side A equal to the sine of angle B over side B. Doesn't matter what the angles and sides are. Okay, we can label it ABC, CAT, DOG, doesn't matter. It's all about having an angle and side pair. Okay, so we must have an angle side pair. All right, the other piece we need to know is that 3 out of 4 parts to the proportion must be given information. All right, so let's take a look at a couple examples. All right, so here's the steps that I'd like you to follow as you solve a triangle for using a law of sines. Okay, step number 1 is draw a picture. So we're going to draw a random picture here of triangle ABC. Which one you label as which is arbitrary. Okay, as long as the sides match up with the angle. So this would be angle A is 64, angle C is 82, and it tells us that side C is 14. The second thing I want you to do is make a list, okay, of each of those parts that we're going to be solving for. So angle A, angle B, angle C, side A, side B, side C. All right, and we make the organized list. That way we make sure we solve for all the parts that we're looking for. So angle A is 64, angle C is 82, and then side C is 14. Fill in our givens in the list, and then we start solving. Okay, and the point that I was trying to make earlier is that you have to have that angle side pair to be able to set up law of sines. So this one sets up perfectly. Sine of 82 over 14 is going to equal the sine of 64 over little a. So when I'm solving law of sines, it is a proportion, so I'm going to cross multiply to solve that. So 14 times sine 64, okay, and that's going to equal a times the sine of 82. I wouldn't type anything in my calculator yet. I would wait until the next step when I divide by the sine of 82. Right, so at this point in time is where I'd want to type this into my calculator to solve for side A. So 14 sine of 64. First thing, make sure your calculator is in degree mode. All right, so 14 sine of 64. And we're going to divide that by sine of 82. So enter, divided by sine of 82. Enter. All right, so we end up getting 12.7 for our side A. So I go back up to my list, and I'm going to fill in 12.7 for side A. All right, now, at this point in time, we can't find any parts about B using law of sines because we don't know the angle or the side. However, we can rely on some information from geometry, which is the triangle angle sum theorem, to find that third angle. And what that triangle angle sum theorem says is that all three angles add up to be 180. So I would take 64 and I would add 82 to that, and that gives me 146. And from that, I would then find the angle for angle B. So in that case, this is 34 degrees, all right, because 34 here would make this equal 180. Now I can set up a second law of sines to find side B. There is a temptation to use Pythagorean theorem, but remember, we're talking about non-right triangles, all right? So we cannot use Pythagorean theorem. So sine of 82 over 14 is going to equal the sine of 34 over little b, and I follow the same process. I'm going to write the steps here, but probably not continue to write all the steps as it does repeat. So 14 sine of 34 equals b sine of 82, right? And then I'm dividing by the sine of 82 to solve that for b. All right, in which case I would get b equals 14 sine of 34, enter, divided by the sine of 82, enter, and I get 7.9, it looks like. For side B. And then a real quick sort of spot check is to just make sure that your largest angle, okay, is across from your largest side, right? Those two should match. Okay, your smallest angle and your smallest side. Those are just some small geometry facts that are true that you can kind of use. It doesn't tell you whether you're right or wrong, but at least tells you if you're, you know, on the right track. All right, so that's law of sines. Let's skip down here and set up the second example for you. I probably won't go through every little detail this time, though. So this just gives us a little bit different scenario. All right, so I have angle A, B, and C, and I know side B is 12. Okay, so angle A is 40, angle C is 22.5. All right, so this looks a little bit different, okay, when I set up my organized list here and fill in what I know. I know A is 40 and C is 22.5. All right, I know little b is 12. All right, so what you'll notice here is that I'm going to have to do my steps in a little bit different order because I currently do not have an angle side pair. So I cannot set up the law of sines proportion at this point in time. However, what I can do is use the two angles that I do know, all right, to find my missing angle. Okay, so I would add 40 and 22.5 to get 62.5, and then I would subtract that away from 180. And it looks like that's going to give me 117.5 degrees. Now that I have my angle side pair, which would be the angle B and side B, right here, all right, I can now set up my law of sines. Okay, so what's that look like? Well, same as last time, right? So sine of 117.5 divided by 12 is going to equal the sine of 40 divided by A. And then the second one to find side C would be 112.5 over 12 equals the sine of 22.5 over C. And I would cross multiply and get answers for both of those. All right. So 12 times the sine of 40. All right, divided by the sine of 112 or 113.5, is that what it was? Or 117.5. 12 sine 40 divided by sine of 117.5 gives me side A to be 8.7. Okay, and then let's see here, sine of 12 times the sine of 22.5. And you'll get patterns on these if you do enough of them, all right, where you don't necessarily have to show every step in the work. All right, or like I have 5.2 looks like. All right, and I've now solved for that one. Okay, so that's really the main idea of the lesson here. There is some other things here about the ambiguous case. That would be that angle side side. So the trouble with that is if you have that scenario, you were probably just told before that you couldn't use that as a similarity or congruency conjecture. And there is a reason, right? The reason would be that if I have a fixed side here and a fixed angle here, and then my third side, let's say, is this one, okay? That third side there, if I swung that, okay, it not only would make a triangle there, but it would also make a triangle there, okay? So it makes two triangles, that one and that one. Even though I don't change the length of it, it still makes two triangles, okay? So that's why you can't use angle side side as a congruency or a similarity conjecture, because you don't know which triangle it would be. So this side here would be fixed. All right, and depending on which way you swung it, all right, you would get two different triangles. All right, in which case we'd have to solve for both triangles. Okay, and the one thing that we'll learn here is that this angle right here, because these two sides are equal in this diagram, okay, that's an isosceles, that means that these two angles are equal, which means that this angle, okay, and that one would be supplementary and add up to be 180, and that's how you find your second triangle. All right, now there are three scenarios here in the ambiguous case when you have angle side side. You could have exactly one solution, and in that scenario, that would mean that second side is exactly the right length. This would actually end up being a 90-degree triangle. All right, you could have no solutions where that third side is too short and doesn't touch at all. Okay, so there would be no triangle in that case. And then the case number 3 is where there would be two solutions, and we would have to solve for both of them. So we're going to take a quick look at that third case. All right, so again, start by drawing your picture. Don't try to draw both triangles, just draw a general picture. All right, so this is 35, this is 12, and that's 16. So you can tell here that we have the angle side scenario. That's the indicator that I'm going to have two possible triangles. So I make an ordered list or an organized list for my first possible triangle. All right. And I fill in the values that I know, which is 35 degrees for angle A, 12 for side A, 16 for side B. But I also want to make an organized list for my second case. All right. And typically when we do that, all right, some of these values are obviously the same in both triangles. That's the 35, the 12, and the 16, the givens. But the way that we indicate that this is a different triangle is a lot of times you'll see us call this B prime. We'll put a little tick mark there in the superscript, okay, to show that this is still the same thing, still the same triangle, but just a different variation of that triangle. And then we start the process, right? So here we have our angle side pair, okay, which is angle A and side A. So that allows us to set up the law of sine. So sine of 35 over 12 is going to equal the sine of B over 16. This gives us a little bit different look than the last examples because we're going to be solving for an angle now. So I still cross multiply, which would give me 16 sine of 35 equaling 12 sine of B. All right, I would divide by 12. Okay, I'm not plugging any of this in yet, all right, because ultimately I'm going to be looking for the inverse sine all right, of whatever that decimal is. So now I'll go to my calculator, 16 sine of 35 divided by 12. So 16 sine of 35 divided by 12 gives me 0.7647-ish. Okay, 0.7647. But I don't really need that because I'm going to use my calculator function here, second sine of my second answer, okay, to get my angle measure of 49.9. We're going to call that 50 degrees. So I go back up here to my organized list, okay, and I write in 50 degrees for angle B. And just like I said previously, angle B in the original, or the first angle you find in the original, and the first angle you find in the Bizarro triangle would be supplementary to each other. So that makes this 130, okay, because 50 and 130 make 180. Now I just solved these two triangles, triangle first case scenario and the alter ego, okay, separately, right? So I'll use triangle angle sum theorem here to find my third angle. So 85 is the sum of those two, so that makes this 95, okay? And then I would set up a law of sines to find side C. So that law of sines would look like this, all right? I would have the sine of 35 over 12 equaling the sine of 95 over C. I'd cross multiply and I would solve. Over here, same idea. Okay, 35 and 130 makes 165. Okay, so that means this third angle is going to be 15. And I set up my law of sines again to find C prime. So I would have sine of 35 over 12 is going to equal the sine of 15 over C. Use my calculator to solve for each of those missing sides, and then I'm finished. All right, so 12 sine of 95. Okay, enter, divided by sine of 35, it looks like. Gives me 20.8. All right, so I get 20.8 for my side C. And then over here, I get 12 sine of 15 divided by the sine of 35 again. And I get 5.4 for C prime. And I've successfully solved for both triangles in that ambiguous case. Probably not a lot of what we're going to do here as far as our lesson's concerned, but still something you should know. Okay. And the area, we're going to save that for another day. Okay. Area of a non-right triangle, we can use, I always call it 1/2 AB sine of C. But you know, they give you all different kinds of variations here. Okay, but for this, you have to know side, angle, side, which fits better into the law of cosines lesson because that's the law of cosines. All right.